Well, my name is Ray Lucchesi. I'm here to talk about storage futures. I am a independent storage analyst. I've been in the storage business about 38 plus years now. My Twitter handle is @RayLuchesi. I blog rayonstorage.com. I do a lot of talks about technology. I'm also a co-host of graybeardsonstorage.com with Howard Marks, who's Deep Storage Net, who also has a gray beard. And we talk about storage. I think our last, most of the time was talking about storage, but last time we did a thing on blockchains, which was pretty interesting. If you're interested in that sort of technology, I encourage you to listen to that. I also have a monthly newsletter. It talks mostly about performance and enterprise class storage announcements. If you're interested in that, certainly see my website and sign up. And I'm also at silvertonconsulting.com. Most of the work I do is with major storage vendors and startups. So I'm here to talk about storage technology. This is kind of the old school. Got a lot of disks, got some flash, got a lot of interfaces, fiber channel and Ethernet, lots of storage, that sort of stuff. But this is old stuff, old technology. New stuff I'm going to talk about today is 3D XPoint, which is a new non-volatile memory. OmniPath architecture, which is a new InfiniBand kind of fabric. SMR, which is shingled magnetic recording. And I'm going to talk about NVMe over fabric, which is the new technology that's coming out to support ultra-fast SSDs, that sort of thing. So the first topic is 3D XPoint. This is a new non-volatile memory. Intel Micron announced this about a year and 3 or 4 months ago at Flash Memory Summit in 2015. Last month, or last Flash Memory Summit, they talked about progress of that. At the time we started this forecast, this was back in last year in January. It was a possibility that 3D XPoint was actually going to come out this year. Doesn't look like that's the case anymore. But anyways, it's a new generation storage technology. It's going to compete with Flash. It'll be faster than Flash, have more reliability. It's being manufactured by the Intel Micron foundry, which is probably the second biggest Flash foundry in the world. And it's potentially available in various form factors as a new form of memory in DIMMs, as SSDs, as both NVMe, PCIe, as well as SATA and SAS SSD. And supposedly it's produced in layers, so you can actually have multiple layers. First iteration is going to have 2 layers, but they can do a lot more over time as they get the technology locked in. So what are the advantages of 3D XPoint? It's approximately 1,000 times the NAND 1,000 less than NAND access time. So it's 10 nanoseconds for 3D XPoint versus 10 microseconds for Flash. This is how fast you can access the storage. It's from a write endurance perspective, you may not realize this, but NAND has a certain limitation on how many writes you can actually write into a Flash storage device. But 3D XPoint has 1,000 times the write endurance that NAND has. And from a DRAM perspective, so I mean, this is both a replacement for Flash as well as DRAM. It's not as fast as DRAM, but it's also not as expensive as DRAM. But it has 10 times the density of DRAM. So if you can fit, I don't know, 16 gigabytes or 64 gigabytes in a server, you now fit 640 gigabytes in a server of 3D XPoint. Yeah, it's seven times the performance of NVMe SSD. So it goes from 95 K IOPS at 9 microseconds versus 13.4 K IOPS at 73 milliseconds. So this is the type from 3D XPoint to Flash. So it's much faster. It's low power, non-volatile DRAM. It's transistor to transistor logic. It doesn't require a refresh. So DRAM today requires a periodic refresh With NVMe, with 3D XPoint, you don't have to have that refresh, so it's a lot lower power. And again, it's 10 times larger or denser in the same footprint, and it's also bit addressable. NAND is not necessarily bit addressable. And DRAM, to some extent, anymore is not bit addressable. It's mostly word addressable, but this stuff you can actually manipulate at a bit level. The big question is, what are they going to price this at? Is it going to be, it's certainly not going to be priced, it's going to be priced somewhere on $1 per gigabyte between DRAM and NAND. That's the only thing they've told us so far. I mean, that's a pretty wide scale, quite frankly. So where could it be used? It certainly could replace flash, both at the server side as well as the storage side, with faster 3D XPoint DIMMs or NVMe SSDs. It will improve I/O response times. It'll be much faster storage at both at the server side as well as the storage side. It can certainly replace any NAND flash SSDs that exist. It will improve the I/O response time. So today, maybe if you had an SSD out at the end of a storage fabric or something like that, you might be seeing at best 100 microseconds or 40 or 50 microseconds of response time. This can take it down by a factor of 5 or 10 of that. It certainly can replace any non-volatile cache. So a lot of the storage subsystems out there today, the hybrid storage systems, have some sort of a both volatile cache and non-volatile cache. And so 3D XPoint can replace that sort of thing today. And today there's actually different technologies out there that exist that are doing this, but they're not 3D XPoint, but there are other non-volatile technologies. It can also replace DRAM. And this is where the view is from Intel has always tried to understand where the technology is going, where they need to be. And one of the reasons behind putting together 3D XPoint is to have a high density DRAM that they can use to support supercomputing environments that need, rather than 64 gigabytes, they need terabytes of DRAM in their environments. Lower cost, smaller volume, higher capacity. And then replacing TTL with denser, low power 3D. So again, because it doesn't have to be refreshed, it's a lot less power. So even though you have a terabyte of DRAM, the power in DRAM would have been exorbitant. But with 3D XPoint, the power is much less. So I've been running this forecasting contest on my website and trying to get people involved, try to forecast where this technology is. This is a little bit old, but the question I had was 3D XPoint going to be GA'd in enterprise storage within a year in 2016? Well, the facts are it's not happening. Micron stated at Flash Memory Summit 2016 that they will have prototypes available by the end of the year, but not production, which at the time we did this forecast contest, we didn't know. So there were a couple of people that actually said that this was going to be XPoint was going to be GA'd 85% probability, or it was actually not going to be GA'd 25%. So this is the guy that won. Happens to be me. There are other contests. I will have to admit that I didn't win, but that's beside the point. So some of the problems from implementing this in technology as enterprise class storage is there really aren't any second sources of this. Intel Micron is the only company that provides it. I mean, there are other sources of different styles of non-volatile technology. Memristor being one, MRAM, PRAM, those sorts of things exist, but not at the levels of density or speed that these have. And again, they were just sampling when we started this thing, so the likelihood of them actually having production before the end of the year was pretty slim. They're going to have to require some boot changes to support NVMe devices, and that wasn't necessarily happening as quickly as they expected. And in order to use it for DRAM, there was going to have to be some changes to the DIMM interface. And the question was how the pricing is. What's the pricing going to really be? And so that was kind of where it was at. But again, Micron said that we weren't going to have it by the end of this year other than the prototypes. So the next thing I'm going to talk about is NVMe Express over Fabric. Now, NVMe Express is a new technology that's utilizing the PCI interface with a new protocol to support high-speed flash. The problem with 3D crosspoint SSDs, for instance, is that the speed of these devices is so extreme that if you were to use them as a flash storage system or something like that behind fiber channel or Ethernet, the Ethernet itself would take up so much overhead, it might not be worthwhile. So by bringing out this thing called NVMe Express, they've taken out a lot of the overhead of the protocol to access the storage. So the storage now can be accessed rather than 100 microseconds, almost down to 10 microseconds. So something like 3D crosspoint, which is on the order of microseconds, it's pretty straightforward. So that was NVMe, but now we're talking about NVMe over Fabric. So what they're going to try to do is implement NVMe over Ethernet, InfiniBand, and Fiber Channel. And today all those things exist from a standard perspective, but there's not a lot of storage out there that are currently using it. So the question is, will NVMe over Fabric come out in the next year or so from a forecasting perspective? So the specification was released in July. There was an interface specification available in 2015. The problem is the server PCI bus is running out of slots. I mean, there's only so many slots you can have for NVMe SSDs in a server. But with a Fabric implementation, you can almost have unlimited number of NVMe SSDs. The intention is that it will work over every fabric. Ethernet, Fiber Channel, InfiniBand, and OmniPath, which we'll talk about later, does require, now it's implemented both in a sort of a packetized approach as well as an interface approach. The packetized approach will not necessarily give you all the speed that you want, but if you have RDMA support, which is it's direct memory access, remote direct memory access from one server to another, in the Fabric, then you'll actually get a lot of the benefits of the speed. There is a new NVMe command set, which can be encapsulated in the packets and works with Gen 5 and Gen 6 fiber channel switches, works with 40 gigabit Ethernet with iWarp RDMA over Ethernet. There are some changes to the NIC software in order to run NVMe protocol. And like I said, you do need RDMA capabilities in your Fabric in order to gain the speed advantages. But this, so the difference between having a native NVMe SSD versus having one over Fabric is roughly 8 microseconds of overhead, which is pretty impressive. And they've got some reference implementations. So what are the advantages? So today, an NVMe SSD at the server provides the best potential IOP performance, which is IOPS per second, as well as the fastest response time. Taking that server direct storage and putting it out in a Fabric at a shared storage solution makes a lot of sense if you can gain the advantages of those speed. And by having NVMe over Fabric, you can start gaining the advantage of that speed. So they've actually shown benchmarks where the server NVMe SSD versus the NVMe over Fabric SSD is exactly the same IOPS, so 1 million IOPS. They did the same sort of thing with response time. It did show that there was an 8 microsecond increase in response time, but 8 microseconds is pretty slim in this world when standard SSD access is probably 100 microseconds. And again, to have an SSD that's shared sitting in a server takes a lot of software-defined complexity, which I'm sure Arjan will talk about here shortly. But by having this thing over Fabric, it's very easy to share the storage. There's some path protection that's available that NVMe over Fabric supports. But effectively, what this all rolls down to is that storage that performs close to what an NVMe SSD will perform in a server, now you can have over Fabric, which means it's shared, which means it can be accessed by dozens of servers, which means you can have hundreds of SSDs or 1,000 SSDs behind a storage environment. So where could it possibly be used? Any all-flash array storage system that supports Fibre Channel and Ethernet storage could potentially be changed to support NVMe over Fabric. It's a new command set, new operations over the Fabric. Obviously, from a speed perspective, there's got to be a lot more logic done at the storage system to support it. But it really simplifies the PCIe versus shared storage comparison, because now the performance is almost equivalent. And would you rather have your storage at the server, or would you rather have your storage at a storage system? I don't know, I'm a storage kind of guy, so for me, storage systems make sense, but whatever. So the current trend for data management services and all-flash storage to be increased. So there are actually more snapshots, more data protection, more replication, more functionality is being added to the storage system to support these flash. But when you're operating 10 microseconds times response time, these sorts of things are hard to do. So my projection, whether it's real or not, is to be less data services will start coming out with NVMe over Fabric. So we just ran this forecast a week or so ago, and it's now, will this NVMe over Fabric be GA'd in enterprise storage by the end of 2017? And the answer was yes. And there's two people that actually came back. One said for sure. And I said, well, what's your probability? He said 90%. I said, okay, 83% probability. Obviously, the switches exist today. So Brocade Gen 5 and Gen switches exist. There are NICs that are available today that all support NVMe over Fabric. Operating system support is available for Linux. But again, BIOS boot support is probably not there. The biggest challenge from a storage system perspective is most of these guys use a SAS backend or a SATA backend. Moving to a PCIe hardware and NVMe software fabric is going to be a challenge for these guys. And you know, how many storage vendors are actually releasing new hardware in the next year or so? That should be year-end 2017. But in any event, the advantages are serious. The technology exists. The hardware is there. It's something that I would think would be a likely thing to happen. The next thing is shingled magnetic recording disks. Not a lot of talk about disks anymore. Disks, old technology. It's been around for, God, 50, 60 years, almost as long as I am. But things are happening there to increase density, to increase speed, increase access. So shingled magnetic recording is a way to record effectively multiple swaths of data. So each of these is typically a track, but they're recording overhead multiple tracks at a time. So it's kind of hard. You can record. When you record, you're effectively overwriting other tracks. That's the problem with shingled magnetic recording. What are the advantages? It's faster. It provides, I'm not faster, but it provides much more dense. This is 1,000 tracks per inch than non-SMR. It provides more density, really, is what it does. So its price of storage should go down. $1 per gigabyte, watts per gigabyte should all go down. Where would it be advantaged? It would replace random access disk storage today in any hybrid environment. Lower cost for archive storage and smaller footprint. And the forecast was, will it be available in enterprise storage by year-end 2016? And it was only one person that said so, and the thought was, yes, it will be available. The problem is it's not normal SCSI. SMR requires almost a file system to be laid out there, because you can't overwrite the same block that you can today. So that's the big challenge with SMR. My last one is OmniPath architecture. This is a new bus, new fabric that Intel is proposing to replace InfiniBand. It's slightly faster. It's targeted for high-performance computing environments. I think the intent from Intel's perspective is actually bury the technology onto the chip rather than having a separate NIC that exists today. There's some layer 1 and layer 2 changes required to support it. It's slightly faster. It's slightly more efficient. Its error recovery is a little bit takes less processing power to do error recovery, CRC-based versus forward error detection, and supports more priority levels than currently exist. Where could it be used? A lot of scale-out storage these days have InfiniBand. Isilon, there's probably 2 or 3 other ones out there that use InfiniBand as an intercluster fabric today. They could certainly come out with OPA if they wanted to. There are scale-out block storages that use InfiniBand. But any high-performance computing, supercomputing environment, and then there's another transport layer for NVMe over fabric. So again, NVMe over fabric can operate pretty much over any fabric. Will it be GA by end of February 2017? Likely not. I think the challenge is, from an OPA perspective, it's proprietary. Doesn't really provide that much of a benefit over InfiniBand. And again, you have to have boot support. You have to have InfiniBand support in storage and operating systems and that sort of stuff. It requires different NICs, host fabric interfaces. That's pretty much my pitch. I'm doing this analyst forecast contest. I've been doing it for about a year. Every month or so, I come up with a new question. I ask analysts to come in and let me know what they think. I was hoping to get Brier scores on all of them, but I don't have enough people coming in to do the forecast. Precision is important, which is why I asked for people to come in with probabilities. They must have an expiration date, to do this well. This all came out of a super forecasting book. And apparently is a good judgment project out there if you're interested in forecasting as a general endeavor. That's pretty much it. Any questions?
I have one. Do you have any information about the price point for the
3D Crosspoint?
Yeah.
Other than the fact that it's going to be So
I'll just yell. Hello? Oh, okay. Yeah, I want to ask the price point.
Yeah, what's the price point for 3D Crosspoint? At this point, they haven't provided any public information. Now, privately, they may be providing information to vendors and that sort of thing. But at this point, the only thing they've led us to believe, it's going to be somewhere on a $1 per bit basis, $1 per byte basis between DRAM and 3D NAND.
Is it still in the development stage then?
Yeah, they're supposed to have prototypes available by this quarter. So I mean, they've had devices, right? They've done benchmarks on devices, but they were hand-built devices. They were not, manufactured devices. My understanding is that if you were a storage vendor, for instance, you'd be able to access prototypes today, but they wouldn't have production till next year sometime.
Is there anywhere we can see the benchmarks on?
Oh yeah, so if you're Flash Memory Summit every year has information. So the last 2016 Flash Memory Summit, Micron had a presentation, and it's online. They'll show you the published performance results of their hand-built 3D Crosspoint. Again, it depends on NVMe, because I mean that's part of trying to get rid of the overhead. But yes, it's available. So I would look at Flash Memory Summit 2016 Micron presentation.
Can you speculate about what the price point might be versus traditional Flash?
Yeah, I have no idea.
No,
I really don't have any idea. It's to some extent it's a question of how much of a market they want to go after, how much of a market they believe it will be, and that sort of thing. They could price it aggressively to try to build a market share, but they're also in the 3D NAND business, so they certainly don't want to wipe that out. And they're also in the DRAM business, so they don't want to wipe that out. So, and it's going to take them a while to get the technology locked and loaded so they get a fairly decent yield, because it's a different technology. It's a more, I would say, chemically complex device than they've done in the past.
Are there any partners in place with this technology?
So Intel, Micron are the two players with 3D Crosspoint. There are other technologies out there, Everspin, Crossbar, and these sorts of things, but they're nowhere near the density that these guys are talking about. So I mean, today you can get, I don't know, a 16 terabyte SSD in a 2.5-inch form factor, something like that. And that's 3D NAND. This 3D XPoint is supposed to be denser than that. So, yeah, that's about all I know. If you're really interested and you've got a big budget, I'd talk to my friends at Micron. That's what I would do.
Okay, thank you.
Yes, sir.
I think you speculated that the 3D XP is going to be less expensive than DRAM. How is that possible? What are they doing differently that makes it lower cost or potentially lower cost?
Well, you know, I think it's less expensive on a price per bit basis. Is it going to be less expensive than price per chip? I don't know.
I can't violate NDAs, but it's about half the cost.
Yeah, how?
Half the cost?
No, on a per gig, right? So
Yeah.
you're paying like $12, $15 a gig for DRAM, you're going to pay $7, $8 a gig.
Yeah.
It just seems interesting to me that, you know, a newer, faster technology, bigger, better, you know, all that good stuff is somehow, that hasn't even come out yet, is somehow going to be less expensive than technology that's been out for a long time.
Yeah. Well, I think it's because it's a new way of doing business, really.
Wait till you have to buy the server motherboard that it runs.
They'll get you on the maintenance, right?
I'm sorry?
They'll get you on the maintenance.
There's a couple things to think about. There's a wide range of the price of DRAM.
Yeah.
So half of a wide range is a pretty wide range. And I think they may also be talking about where they'll get. And again, none of us will violate NDAs, but you know, if the technology's available in the first quarter, you know, all of a sudden, when they get into a real manufacturing ramp, this is Intel we're talking about, and Micron, so they do know how to produce a lot of bits.
They're going to be pretty aggressive with it.
Yeah, I think the challenge is because it's new technology and that sort of thing, it's taken them a lot longer to get to a point where they've got prototypes out and stuff. But if they really want to build a market, then they got to price it right. You know, and if they can get the volumes up and get the yield up, then maybe they can bring the prices down.
I mean, Intel's got a motherboard coming out with 128 slots for memory. Yeah. I was just saying, Intel's got a motherboard in prototype right now with 128 memory slots. So just do the math, how much density you can get in one U and under 600 watts.
Yeah, pretty impressive. Any other questions? All right, well, thank you very much.